Good afternoon, everyone. How do you guys feel? All awake after the lunch? Thank you so much, Raj, for actually waking us up with his short monster or something. Okay, so I'm Christina, and I work for Cisco Labs. Been in the industry for the past 4 years. I'm very passionate of not just the functional automation, but also the non-functional automation testing as well. So yeah, this is, you probably would have seen me in a couple of conferences, and you can follow me on Twitter and also connect me on LinkedIn as well. So have you ever used an application, a mobile application that actually made you thrash the phone? I've used one. Anyone? Seriously, it has been super slow that I really broke my phone. No, I'm kidding. Oh, by the way, a piece of advice. Before getting married, just make them use that app, because patience is a virtue. Yeah, and we need that in married life. So jokes apart, today we're going to talk about load down your mobile app, right? So end of the day, we are all end users. We've been using different mobile applications, and so do our mobile app end users as well. So as end users, you've been frustrated using slow applications. Same would be the feeling for guys or people who are using your mobile apps. Do you ever wonder that performance is also key for mobile applications? Right? Yeah, because it really gets your end user frustrated, right? So today, this is basically the agenda. So I'm going to give you insight of the performance testing, the aspects of it, and then we'll dig a bit deep into the aspects, and I'll also have a few demonstrations on a few open source tools on how we can actually address these issues, right? So first of all, this is a survey that was actually done in 2015. So that's like 4 years back, and the expectation was super high then, right? This was a survey done for mobile end users. And sorry to say, like most of the people who took this, about 50% wanted the application to respond in 2 seconds, like 2 seconds. And there's like half of that percentage, or a significant amount, who've actually said they want the application to respond in a second or even less. So this is the expectation in 2015. We are hitting 2019. Now the expectation has definitely grown, right? And then there's also this, in this survey, they asked if there's this app is slow, will they be, as in the end users will reuse the app again, or will they, how many attempts will they do before moving on? So the maximum was like, most of them said 3, right? Less, or even there was a significant amount who said less than 3, right? So that's a wake-up call. We'll lose our end users if we don't actually worry about the performance, right? So, and if your app is super slow, it's draining your battery, then end users just move on. If you have a competitor, that's it. They're just going to move on, right? And then they also, either they just stop using it and then just leave it just lying there in the mobile, or just uninstall the app and just move forward. So this is basically the issue, and we need to start looking into this, right? We've all written functional tests, or we do some kind of manual tests or so on, right, for when it comes to mobile. But do we do the performance? Do we see the performance in depth? So that's the question that is there, and why do we feel more reluctant when it comes to mobile compared to the desktop or web applications? So as you see, when we talk about mobile, there's multiple clients. So when I say multiple clients, you will be wondering, okay, there's iOS, there's Android, there's other few operating systems. What is she talking about? No, so it's like multiple different mobile devices, right? Now we're not just talking about, if you take a iOS, there's multiple different mobile devices. It has different RAM sizes, memory sizes, and so on, the battery consumption, and so on, right? In the same way, when it comes to Android, there's different brands. There's A series, B series, C series, so on. So then there's the technology. So when it comes to web applications, it's just HTML based. But when it comes to the mobile, either it'll be HTML or native. And when do you guys use mobile applications? Anyone? Okay, so like in restricted conditions, right? Like when you're in the bus, in the tube, in the subway, somewhere when you are in a rush. So there's restricted bandwidth, or when I say mobile data and so on, it'll be way restricted from using it on a web application or on your desktop, right? So these are the main issues where these are challenges. And when these are challenges, we need to face them, and we need to look into these aspects when it comes to performance, right? So these are the main aspects of mobile performance testing. So we always consider the survey API performance testing. So even when it comes to a web application or desktop web application, we think of the API performance. But when it comes to mobile, there's other aspects like device performance. As an end user, you guys would have complained saying, this particular app is draining my battery. This particular app is using too much of my data, or it's just taking too much of memory. So there are actually apps that, or mobile app providers who have a standard app, and they have a light app which works with less network or uses a less amount of battery, right? And then, so these are the main aspects that we need to consider, not just the survey API. So first of all, we'll talk about the server API performance, right? So this is basically mobile API calls, talking to the server, whether the response comes in the expected time, and so on, right? How many of you use this aspect of mobile performance testing? Cool. So basically, I'll just be showing this concept of how we can do survey or mobile survey API performance, right? So basically, this is the idea, right? The basic idea: the HTTP request goes to the backend, and then the responses come back to your mobile application, right? So we're going to, most of the tools that are available for this survey API performance testing, there are paid tools, multiple paid tools as well, and there's open source. So today I'm going to actually demonstrate JMeter to you guys, but well, as JMeter, it has a couple of restrictions when it comes to like using multiple users and so on. So there's various other paid tools that actually help out with such constraints, but let's just start with the basics, right? So basically this is the idea of it. So we're going to have a recorder, and it's going to literally record the calls that go from the mobile to your server, and the responses will also be grabbed, right? So this is the basic idea. So we're going to give the your mobile the ability to trust your the load running test, right? The test application, and then with the proxy settings, we'll be able to record it, and then you work on those tests, right? To run your mobile, or you basically will mimic the mobile application to run the tests on the server, right? And then once you do, you will be able to analyze the results. So this is basically the demo. Okay. So this, I'm basically starting my JMeter. So I'm using JMeter 4. and I am using the recording template. Right, so in that you have the HTTPS test script recorder. Then you set the port, right? And also I'm getting my the IP because I'm going to record the tests on my mobile device, right? Next, I start the script recorder because it's going to create a certificate which is valid only for 7 days. So I will be sending it to my through email, and I'll be using that in my mobile device. Right. So this is my mobile device, right? So I've already got the certificate installed, but just for you guys to have a look at. So there is an expiry date as well, so it's like 7 days, and so this is basically the CRT file with all the properties, right? And just to be sure, I'm switching on airplane mode and then going into Wi-Fi, and I'm setting my proxy. So you can, so this is how it's done on iPhone. Android is more straightforward. Right? And you set the proxy, and then we'll be now able to run the test. So basically, I'm going to start the test or the recording on my JMeter, and then start using my mobile application and start recording the calls, right? So I'm using an e-commerce application. So as you can see, the visual feedback that's being given is there's multiple API calls that goes through when you just load the application, right? So as you can see, once I load the application, there was multiple calls. Then there's a post call that gives the details of my particular application. So I love my shoes, so I'm searching for shoes. Okay, so yeah, there you go. And there's more calls because there's various different get APIs because there's various different shoes that have appeared. Okay, so specifically selecting one, so you can see that the recording is taking place. And now what you can actually do is look in, so if you actually have this as your own app, then you'll be able to understand which APIs are there, because you can talk to the developers, narrow down which aspects that need to be tested when it comes to performance testing, and then start testing. So I'm just going to run this test for like about 5 concurrent users. And I'm just going to disable all the other particular controllers. I'm just going to use only the first where the opening of the app API. I'm just going to run it. So I've saved the, I'm saving the test or the JMX. And you can see that the tests are running, and yeah. So as I mentioned to you, there are a few restrictions when you have to have a massive amount of users. Yes, as an open source tool, JMeter doesn't handle it much, but then there are various paid tools that actually work with JMeter, right? So we've now had a look at the server API level of performance testing that a couple of you have already been aware of, but this particular aspect, device performance. So as we know, as I've already mentioned, we certainly complain that a particular app is draining your battery or it's using too much of memory, right? And the app takes so much time to load or start up. And it works with this particular phone, but it doesn't work with this particular hardware, right? Or it works on this software, but it doesn't work on the older version of Android, right? So not everyone's using the same device, but we have different end users, right? It's like every device is kind of unique. So in that way, are we ready to face such issues, right? Is our application ready to face such issues? Then we talk about network performance, right? In that, if we have different end users and they are from different parts of the world, are we sure that it works in a certain continent with the network speed that they have, and in a different continent it works with the network speed that they have? Or is there any sort of packet loss? Is there any certain jitters and so on, right? So these aspects we need to look at, and how can we achieve that is the question. So we've come up with this idea of using Appium. So there's two different frameworks that we are using. One is with Android and one is for iOS. So we've basically trying to get the performance data and then comparing or creating a trend technically and understanding how it works. So I'll give you a basic insight of what was the main essence that we used to start with this framework, right? So currently, with the, how many of you have used Android Profiler or have seen it? Okay, so cool. So basically, this is pretty much similar to what Android Profiler does, right? So Appium is using ADB dump system and giving us the information, and we'll be able to either understand a trend on aspects like memory info, CPU info, battery info, and network info for as of now, right? So there's a basic command where you use get performance data, you specify a particular package, and then use a perf type as mentioned, like as CPU info and so on. And then particular timeout, say. So a particular poll time, like about 5 seconds or 10 seconds, depending on your particular application, right? Depending on the performance requirement for your particular application. So before actually writing these tests, you need to narrow down. So that part of the whole performance requirements need to be clarified. You need to understand what is important or which particular scenarios that you need to do performance testing. So if, for example, we do mobile functional testing with Appium, so we just have a few other scenarios which are part of the performance package, which helps us to basically create a performance trend. So let's quickly have a demonstration on this. So this is my Android Studio, and I'm going to first show you how Android Profiler works, because not many of you have actually put your hands up. So I've gone into my Android Profiler, and I've already got my emulator set because for demo purposes. But when you are actually running tests, make sure you run it on real devices to actually get the right output, right? So what I'm doing here is using Android Profiler, meanwhile doing some activities on my emulator, and you can see that there is a memory trend, and you can see that there is the stack usage, the native usage, and so on. All those details have been displayed. So there is a specific documentation for you guys to actually understand these aspects when it comes to performance, which is part of the Android Profiler. So you'll be able to understand this, and once you do understand that, then whatever data they get through the Appium test is also, you'll be able to understand that quite easily. So this is basically the same thing. I'm going to do it with test automation using Appium. So as I mentioned, I'm using the command that I showed. So this is very basic for you guys to understand and take it back and build on this, right? So I'm giving a specific call time, a poll time, and then we'll also specify the particular package. And currently I'm using memory info, and I'm going to take the total proportional set size, or the RAM, basically the RAM usage, and I'm going to compare it. So initially I take the RAM usage and then compare it after doing the activities with this particular application. Okay, so that's what I'm doing. So I'm initially taking the total proportional set size, right? Just for you guys to have a look at it. So we basically use a couple of APIs to send these and create some trends. But just for you guys to visualize it, I'm just going to print it on my console and you'll be able to see it. So I'm just changing the usage time. And also, currently I'm going to do an assertion where I'm going to compare the total proportional set size and say that if it increases more than 5% of how much it was, then please fail the test. So this again depends on your particular application according to your performance requirements. So I just want this test to fail now for you guys to have a look at it. So that's why I've given a 5% assertion. So as you can see, the same thing that I did manually with Android Profile is what the test is doing. And you can see that I print the whole memory info that's being grabbed. Right? There's total proportional size, the Dalvik proportional set size, and so on. So all these details for you to understand each of these aspects. There is a very good documentation provided by the Android Studio guys. So you can see that the test has failed because the assertion, obviously, it was more than 5% of the previous value. So those are certain values that are being printed. So next we'll look at the network info, right? So there are other aspects like CPU info and battery info as well. So let's also just look at network info. What are the aspects that come and how can we compare those values as well, right? So I'm going to get rid of the total proportional set size comparison. Okay, and I'm increasing the particular usage weight, and yeah, ready to run the test. So as the test starts at a point, once the test or the particular application starts, you'll be able to see the particular network values being grabbed and printed. So there is the transmitted packets, the received packets. So that's the received bytes, the start time, the other operations that are running in the system, the mobile, and yeah, the transmitted packets and the received packets, the values. So what you can actually do is create a trend with these values, right? Give us particular poll time, keep checking, and create a trend, and then understand how this particular, the flow of your performance, or particular, whether the app is actually affecting your mobile mobile performance, your mobile device performance, or whether there is any network issues that the particular app is having, right? So that's basically the idea of how we achieved or what we've been doing with Android and Appium so that we'll be able to get performance data of our mobile app performance in the particular device, right? And then next we'll have a look at how this can be achieved in iOS, right? So it's not as straightforward as Android, where you get like perfect data and then you create a trend. But with iOS, you can use something called instruments. Anyone's used instruments before? Instrument, yeah, cool. So yeah, so basically we'll be using Appium to record with instruments, run the particular test, and meanwhile the recording will be taking place, right? So for that we need to keep a point that you will have to start your APM with relaxed security, otherwise the recording doesn't take place as of now. And also you have to pass the arguments, like if you're looking for a particular profile name, the timeout and so on, and then you start the recording, right, with that particular profile name. You can use multiple profiles as well. For now, for this demonstration, I'm going to use the time profiler. So when I say time profiler, I'll just show for those, because not many of you have used instruments, so I'll show you what are the other profiles that you can use. Like again, you can get network info and stuff like that on iOS instruments as well. And then once the recording is done, you save the trace file in a, you zip it up and save it, and then use that file to then create your trend, right? So let's quickly. Okay, so then we have the open developer tools on my Xcode, right? And then we are going to run the particular tests manually, right? So I'm using time profiler. There are other values as well, sorry, other profile names as well. Then I'm going to run it on iPhone X, which is actually not available in the Apple Store, but yeah. Going to run, so this is basically whatever I'm going to do, but I'm going to do it manually at the moment. So you can see that I'm just going into my simulator, right? And I'm going to do so this is a free app that I've used, right? So when you have the developer code, you'll be able to narrow down which aspects are getting affected as well, right? So you can see that there are a few spikes, but this is not a very complicated particular application, so there's not much of performance issues as well. So you can see that there is CPU usage that I've grabbed. So again, same way you can get network info and so on as well. Okay. Then you can use the profile mode, the narrative mode. Again, this is on instruments, so not currently the particular profile name is the only value that you can pass with APM. Okay, so once if you've done this manually, you will save it, or you and then save it for other usage. So now we're going to do the same thing on with our APM tests, right? So I'm going to start my APM basically with relaxed security. And then I'll be running a few the same tests multiple times, right? So before that, I specify the time profiler and then start recording. Okay. And then finally, I would store the particular trace file, and then after that you can build your tests on that. So now we can actually see that I'm starting my APM with relaxed security. As of now, it works with relaxed security because iOS driver. Okay, so now the code is set and we can run it. And this time I won't be able to show you values, right? We'll only be able to see instrument trace file, right? So the test has started running. It's going to do the same thing that I just literally did manually, right? But a couple of times. So now the trace file literally should be saved. So let's go have a look at that. So I'm opening up the trace file with my Xcode or the instruments file. So it's saved with the time profiler, and if you actually have the developer code, you'll be able to match it up, right? And also there are certain ways that we can break down this file and create a trend as well. Okay, so you can see that it's gone into the main, and then you can go into a particular class and have a look at it, right? So this is basically the idea of what we've started doing with device and network performance for our applications in Android and iOS. So I've just shown you like very basic or the very starting stepping stones that you can actually start with, right? But then this is not it. When I said we have multiple clients, we need to simulate real mobile devices, right? It's because it's not just checking it on one iPhone and checking it on one particular Android phone. There's various different clients, and we need to check it with different memory usage, RAM, memory, and so on, right? So we need to simulate a real device farm or something of that sort to actually get this thing going, right? Next challenge that we have is to simulate different networks, right? So for example, as I said, if you have end users in different continents or different areas, right, it's not the same network speed that is in the US which is found in another place, right, or another continent. It's different. So if you have end users who are using your application in various parts of the world, then you need to simulate the network speed and so on. So these are few things that also we need to add on to actually understand the mobile app performance in our particular mobile device and so on, right? So if these things are incorporated, then we can be happy end users, and we can also have happy end users as well. So our customers and our clients will be very happy to use our applications, and we won't lose them for other competitors, right? So these are few of the sources that I've used, and hope this was helpful for you, and you guys can actually go back and use them in your industries or start investing on the ideas that I've given you. And thank you so much.